Okay, I was going to say you turn your tally light off also. Okay, personally speaking, for me, in all honesty, you're like my hero. Because since I was 13 years old, I've been fascinated with gravity. I told my father that one day I was going to do something with it. I didn't know what. So now here you are. So the papers, the research that I've read on the internet about you says that in 1992 is when you first started this experiment, or prior to that. So can you elaborate how you started this?
I was working at Tampere University of Technology, and in fact I was working with high temperature superconductors, which are very interesting materials because they can capture the magnetic field of various configurations, and they have pretty unusual properties. At that time it was in the center of the attention of all the scientists of the world, and I was working with rather big samples with a diameter of maybe 6 to 8 inches, which was unusual even at that time. And I noticed some anomalous behavior of those superconductors, and I noticed that several objects, or any objects which were placed over the superconducting disk under the interaction with the magnetic fields of high frequency, all those objects lost some part of their weight. We checked and rechecked our experiments before we were brave enough to publish our first article, and it appeared in 1992 in the magazine Physica C, and it was met with great interest by the scientific community. And at that time we used the term gravity shielding because we thought it might be connected really to gravity shielding, but later we decided not to use that term because it was not right. Now we use the term gravity modification, or to be exact, it's the modification of local gravity field. And though, to be honest, we do not know exactly the mechanism of gravity, we are only beginning to understand it, still we are already able to use it in different aspects and for different purposes, for scientific, industrial and others, and we think that this direction has a big future.
I'll grab a chair. Thanks. Wow, that's great. That is spectacular. Okay, well that's much better.
Do you just want to run over them, just check, seeing the sun's come out, just make sure we're still good? I'm pretty sure we are. But
yep.
Just double check.
Good. Turn the timer off there. Okay. Okay. Let's see. True, not true. Columns, Facebook. Okay. Yeah. I pulled something off the internet here, and it says that originally. Now I don't know whether this is true or not. This is the first time I've ever read this particular thing since I've been reading about you. It says that it was kind of an accident. You were spinning a disc and some smoke. Is that true? Was it an accident or?
It was kind of an accident.
I just told you there a second. We just got lost in this dust going in front of the lens. It's coming up on the picture.
Yeah.
Yeah, it's kind of.
I'll trust you.
I think. All right, we're good now.
Okay.
Okay, you can say it was practically by accident because we were making our research and we were making the measurements of the weight, and we were using a cryostat, and we were working late in the evening, so one of my colleagues came to the laboratory and he was smoking his pipe, and he blew the smoke over the cryostat, and then a strange thing happened because that smoke approached the cryostat, hit some invisible barrier, and then went straight upward. It was a bit unusual, but that gave us a very good idea, and later we used a barometer in order to check up the air pressure over the cryostat, and it happened so that the air pressure in the projection area of the disk was lower than in the surrounding atmosphere, and the difference was up to several millimeters of water or even mercury. So this difference could be felt not only inside our laboratory but on the second floor above us, and we were able to show that we really deal with a well reproducible and very effective phenomenon.
Great. I'm glad I asked you that. Okay, so can we let's see. Okay, so can I get you to talk about the disc?
Yes, sure.
It looks like a weight that people lift. Okay.
So the disc is made of yttrium, barium, copper ceramics, and it has two layers. That is very important from the scientific point of view. So when we put the disc over the magnets and we cool it down to the temperature of liquid nitrogen or liquid helium, because of the Meissner effect, disc is levitating over the magnets and it can be rotated. And again, with the magnetic field, it can be rotated with big speed. We use the rotation up to 5,000 rotations per minute, but later we made a special installation which allowed us to use much higher speeds. And every object that is put over the disc loses some part of its weight. In the stationary mode, the loss is not big, it's about 0.1%. But when we rotate the disc and use resonance frequencies of the electromagnetic field, we can increase the weight loss up to 2%. And if we increase also the rotation speed, we can reach the maximum values of 5% and at some peak values up to 9%. The only thing that keeps us from better result is the rotation speed, because the disc is a ceramic one, and even at 20,000 rotations per minute we have very big forces which tend to destroy it. So we should keep it always in mind. But as I used magnetic suspension system because of the Meissner effect, it's possible to rotate it up to rather high speeds. The maximum that we used was about 30,000, and then we had to make some special protection made of plastic materials so that we could strengthen the structure of the disc. In that case we get really good values, and also we have some secrets. They are connected with the resonance frequencies of the magnetic fields and special configuration of the solenoids. But in general it's a rather simple experiment, and it can be reproduced in a normal laboratory at any university.
Can you see these discs?
Yeah, I pulled out then. There's a bit of a mic, but we
I don't care.
get that in editing.
Yeah. Okay.
What do you mean?
Yeah. Mayumi is my wife's name. By the way, I'm thinking about it because I'll forget later. You have a business card, just so you know. Okay. That's a play on my wife's name.
Thanks.
Spelled differently.
I see.
Yes. She's such a sweetheart. Okay. All right, so tell us if that's okay. Now, the superconducting material, if it's a secret, that's fine. But if you're allowed to elaborate on basics of the material?
No, it is not secret. We have two layers. One layer is normal superconductor, or yttrium, barium, copper, with the formula 123. It's well known in the world. And the second layer is practically the same material, but it is not superconducting. It is normal conductor. So by special heat treatment we can arrange both layers in such a way that one layer is superconducting and another is normal conducting layer. When we rotate the whole disk in the magnetic field, normal conducting layer produces a lot of electrons, and they move to the superconducting area, and they become not electrons but Cooper pairs, and they form what we call in physics Bose-Einstein condensate, which has unusual properties, and one of the main properties is that it has the property of superfluidity, superconductivity definitely, and it can also interact with subatomic particles that exist around all the objects and practically form the whole universe. And by using this interaction of our superconducting material with subatomic particles, we get very unusual reaction, and we can to some extent change or modify local gravity field. If we go to a bit deeper physics, we can say that we have the ability to polarize space around this rotating disk, and using this polarized space or polarized physical vacuum, we can definitely manipulate gravity. I can't say that I'm an expert on gravity. I never was, and I'm afraid I never will be. But I want to understand gravity and to make experimental research in this area, because there are a lot of theoretical works, and I'm thankful to those theoreticians who also studied our experiments and helped us a lot. But the experimental part still remains, from my point of view, the key point to overcoming gravity and using it for our future, for our purposes, for all our needs.
Great. Could you show me with your hands? I'll probably have a diagram and three-dimensional animation, but I think, from what I was reading, that it looks like donuts. Is that correct?
Yes.
And let me elaborate on that. Okay, go ahead.
If we speak about the magnetic field, yes, it goes like donuts. But if we speak about the production of gravitons, if they ever exist, because these are still hypothetical particles, we have the emission of gravitons, which follows the projection of this disk, and it goes to space in one direction, and we can change the direction of the flow of gravitons. Or if we are not sure that these particles are gravitons, we can speak about gravity waves, which propagate in space and again influence all the objects that are in the projection area of the disk.
Now, in the disk, is the weight loss in the center, or is it run?
No. We use this configuration because we also have a current which circulates around the disk, and it increases the effect. And the increase of the effect is because of the fact that we should create the maximum density of electrons or Cooper pairs inside the superconducting materials. That is the key to success. That's why we are rotating it with great speed. That's why we use high frequency. And the result of this density is when a certain critical density of electrons is reached, we have that interaction of Bose-Einstein condensate with the subatomic particles. If we speak about subatomic particles, what I mean? This is a bit... Well, it's not an unusual question in physics. Usually we deal with vacuum, and vacuum, normal vacuum, is considered to be empty, entirely empty. Still, all the transmissions of electromagnetic waves, which go to space shuttles to the moon, they propagate in space, and they propagate like waves. And wave is only a distortion of the media. And if vacuum is entire emptiness, there is nothing to disturb, nothing to distort, and then the waves cannot propagate inside it. Also, if we refer to Einstein's theory, he says that gravity is the bending of space-time continuum. It's right, maybe. But if we want to bend something and it is entirely empty, then it is impossible. So we have to admit that there are particles which constitute physical vacuum. These particles are several magnitudes of order smaller than the electron, but they constitute that physical vacuum which has a lot of energy inside and can to some extent interact with normal solid bodies. And the theory of zero-point fluctuations of vacuum was created by American scientist Harold Puthoff, Bernie Heisch, and Dr. Rueda. And this theory is a very interesting one. There are a lot of debates about it, but it's the only theory that is able to explain the mechanism of gravity, the mechanism of energy, and practically how the whole universe was created. It's a new approach. The idea of ether is not a new one. It existed through centuries, but now it got a very good expression in this theory with good mathematical formulas. And in my work I try to use this theory. So I'm very grateful to Harold Puthoff, and I'm also grateful to Jack Sarfati, who is a kind of his opponent in the scientific world, but with different approaches to the same subjects, we can have really the solution of the problem. Also, most of the theoretical work which is behind my experiments, most of this work was done by Dr. Giovanni Modanese, who is one of the leading European theoreticians in the field of gravity research. And it's enough to say that he made his PhD in Germany, and his research was in the field of general relativity and special relativity of Einstein. So we don't break any laws when we are working with superconductors or experimental gravity installations. We are just trying to follow all the rules, but sometimes we observe the phenomena which are unusual. We call them anomalous. And we report honestly what we find. And we would like, of course, to attract the attention of the scientific world to all these problems, and to organize a deeper research in this field, because it will definitely improve our understanding of the universe, of the creation process, of the gravity forces or gravity field, and it will allow us to use all this mechanism for the benefits of humanity.
That's great, great. Okay, now I was reading somewhere where, and of course you mentioned it, if the disk spins faster, I guess you get more of a field around it. If you were to say have a disk made of that material, and if it were possible to spin it, would you, I'm trying to figure out how to phrase this, and if you were to say spin it, I'll use just say 6,000 RPMs, disk, maybe say 3 feet, would it actually be able to levitate more objects or more weight, or is it something else at work here.
Well, first of all, if we rotate such big disk at terrible speeds, it will fall apart because the materials can't stand this load. But to be absolutely honest, now after 12 or 15 already years of research in this field, we came to a conclusion that it is not necessary to use superconducting materials in order to modify the gravity field. We can use rotating magnetic fields, and we can turn to normal conductors, which is much easier, and this method has a lot of advantages. So we use superconductors just as model materials because we can put different magnetic fields inside, and we can freeze magnetic fields inside the material. So this is just the unique properties of the superconductors that we used. So it's possible still to base the research on superconductors, but we can go further. And in order to create flying vehicles or impulse gravity generators, we can use normal materials.
Okay, have you ever tried, I was reading something about NASA. They've got an experiment that they evidently released, I guess weeks ago. They haven't released it, or somehow it got into on the internet that I read about it. But they have something that's 20 inches wide by 48 inches tall, and I guess it's like a tube from the description of it. If you were to stack those discs, would you get more power? Say able to? I guess what I'm trying to get at is, could you lift heavy objects like, I don't know, bricks or, you know?
Well, if we put one disk over another, and they can't be put just like this, we use different cryostats, and we can rotate the disk even in opposite directions. Yes, there is some gain in the weight loss, so it's possible. The experiments that were made in NASA, according to my knowledge, they used the principles that I published in Physica C in 1992. Then we modified the experiment and used bigger disks. So I consulted people from Marshall Space Flight Center on this topic, and they got some unusual results. But unfortunately, the whole project, which was called Breakthrough Propulsion System, it lost practically all the funding, and the research was stopped at the final point. They made a cryostat, they made the disks very close to the requirements that we supplied, and we were ready for the tests, but the program was stopped, unfortunately. And that is quite understandable, because this research is entirely new, and by the way, it doesn't require much money. And usual approach to gravity problems, to rockets, to shuttle programs, all these things take lots of money, and that also means that a lot of people are involved. They have working places, and the companies gets millions from this. But finally, what we get as a result is a shuttle, which is not a reliable construction at all. And it was good for the 20th century, but it is not good for the 21st. We have better proposals, we have cheaper variants, and we have more efficient solutions for the exploration of space. So I was always hoping to be able to organize the Institute for the Gravity Research based on the best physicists of the world. It might be under the guidance of NASA or European Space Agency or Russian Space Agency or British Aerospace, whatever it is, but it should be international, because the problem is too complicated to solve it only in the United States or in France or in Russia.
If you were to, the smoke that your colleague blew over that, is it possible to see the actual rings that go around? Is there some way of looking at that?
No, it's the smoke simply approaches this area and then it goes up, and that's all. And my poor colleague, I can't even tell his name because, unfortunately, and everybody knows it, it is not allowed to smoke in the lab. But it was evening time, and he was exhausted, and he was going home, and he was just curious what we were doing so late. That's why he. So I'm always asked, do you know that it is not allowed to smoke in the lab? Yes, I know it very well. We never smoke. We usually don't break any laws, administrative or physical. We're just very intelligent people.
I didn't know that, so I don't want to get you in trouble. Okay, so what would happen if... Okay, here's something I was wondering. Have you ever... I don't know how you get the disc to a spin. Maybe you got an electric motor under it or something. But if you were to put a pan of water, maybe 2 inches thick, maybe 2 feet by 2 feet, would it have any effect on the water? Would the water... I mean, could it possibly bring water up? Is that possible?
Well, what will happen that all water that is put over the disc will lose some part of its weight. So if we put 1 liter of water, it will weigh not 1 kilo, but 2% less, or 1% less. That's all. We can't use this method for the turbines or for the production of energy at present. But I'm sure that based on this principle we can later construct the installations which will be able to provide us not with entirely free energy, but with the energy which is very cheap and very efficient. If we speak about free energy, again, I don't want to break the second law of thermodynamics, but the second law of thermodynamics is valid only for closed systems, and it is well known to every physicist. But they always forget that we deal with physical vacuum. That means the subatomic particles that are present everywhere, in the air, inside this body, inside human tissues, and we can take the energy from this field of physical vacuum and we can use this energy. But how to organize the interaction with this physical vacuum, it's another question. So there are various approaches. And there are pages on the net which are called American Antigravity, and it's a very big work by Tim Ventura. And I have a small abstract there, and there are different ways to polarize space and to have the interaction with physical vacuum. We can create high magnetic fields, we can create high electric fields like Byfield-Brown effect. We can also have extra low frequencies, and here it's necessary to mention the works of Professor Fran de Aquino from Brazil. And it's also possible to use rotating magnetic fields based on the works of Professor Searle from Great Britain. We can also rotate normal gyroscopes, and I'm always thankful to Professor Laithwaite, who slightly disturbed the traditions of the science in Britain, but still proved that we can create gravity forces, special gravity forces using usual gyroscopes. And we can also use special grids, very thin grids, and topological effects in order to polarize space. And we can, of course, use superconducting materials and the properties of Bose-Einstein condensate. And there are also some other methods. We know some of them, and we know, and maybe we don't know all of them, but there is a big field of unstudied material in front of us. But we can also use the combination of all these methods, and this will definitely give the best results. So we're slowly moving in these directions, using the knowledge of different scientists from other countries, using theoretical material that exists in this area, but also using intuition, because we're pioneering this work, and this task is extremely difficult, because modern science, it's like whole inquisition. We can't say we invented or we made anti-gravity. By the way, we never use the term anti-gravity in our laboratory. We use gravity forces which can be attractive and which can be also repulsive. And by the way, if superconducting material can demonstrate both repulsive and attractive forces. For example, if we have a superconductor and we have a magnet, and we put the magnet over the superconductor and cool the whole system down, then we take the magnet off and the superconducting disk follows it. And we can rotate it just by hand, and it will continue rotating under the magnet. So we have the magnetic field, which scientists say is frozen inside the superconductor. Well, the word frozen is not quite acceptable. This is a very interesting phenomena, practically same as levitation, but the mechanism of all these things and the flux and the properties of the electrons, these things are not studied in detail, they are not understood in detail, and even the mechanism of superconductivity, high temperature superconductivity, is not established, and Nobel Prize is still waiting for the scientists who will give us the direct explanation of the mechanism of superconductivity. So it just proves that the subject is too difficult and too unusual to work alone or with a small team. We need the efforts of the international community. That's the key to success.
That's great. NASA has an ion propulsion system. Are you aware of that? That particular system, they've got Deep Space 1 and Deep Space 2.
Yes.
Now that are being propelled by that. Have you ever experimented with using gases, maybe like a xenon gas, spinning a xenon gas perhaps?
If we speak about propulsion systems, I think that it's better to refer to another step of our work, which is called impulse gravity generator. And this work attracted not only the attention of NASA, but also the attention of Boeing, and Boeing Phantom Works in particular. They have a special research in this field. So if we refer to this field, this is a bit different, but based practically on the same mechanism. So we again have a superconducting disk, which is made of two layers, but thermal treatment and chemical composition is a bit different, so we have a different crystal structure. And we organize a high voltage discharge through this superconductor, and it's a very unusual experiment. I think nobody in the world ever repeated it. So we use the principle of the Van der Graaf generator, and we have the difference of voltages close to 2 million. We have superconducting material which is cooled, and the whole system is in the vacuum chamber. And during the discharge, again in the magnetic field, during the discharge, the superconducting material emits gravitational wave, or a portion of gravitons, which propagate in space with extremely big speed and are able to provide some pressure or interact with the materials in the area, in the projection area of this impulse. So this interaction is very short in time. It's femtoseconds, or well, let's say 1 million of a second. And we have this impulse which hits the subjects or all the objects in the projection area and propagates further, not losing any energy, at least measurable energy. So we began these experiments about 6 years ago, and our first article was published on the net in the year 2000. And this is the theoretical basis of this work was done by Dr. Giovanni Modanese. And this is a very serious research, and it has extremely good potential, because this gravity impulse is able to propagate with the speeds close to 64 C, which is 64 times faster than the speed of light. But we have no limitations, because we don't work with any material objects. They practically have no mass. And this impulse is able to interact with light. We made rather interesting research. The results were published in the magazine of it's the Journal of Low Temperature Physics in August of 2003, and again it's with Dr. Modanese. So this is another application of high temperature superconductors and their discharge, and the force of the discharge can be rather strong. At first we were able only to work with the pendulums, and just only the best thing that we were able to do was to push a thick book away from the table. It was standing, just a vocabulary. But now when we started, when we were working with this program for several years, and I have a very good team, we were able to increase the power of this beam, so now it can bend metals, rather thick plates, and it can create holes in fragile materials such as bricks or cement or ceramics. And again, if we say honestly, do we understand in details the mechanism, how it works? Not everything, if not everything at all, but we're working on it. And for the purposes of space research and for the communication, very fast communication, we can definitely use this impulse gravity generator. And we should also study these effects using different approaches, and the most complicated, the most precise equipment that we have available in the world. But we were measuring the propagation speed of the impulse. We used 2 atomic clock, and we had the distance of slightly over than 1 kilometer. So we repeated these results several tens of times, and I'm pretty sure that we got very exact values. Still, knowing the reaction of the scientific community, or what we call politically correct science, we're a bit afraid to publish the results openly, but sooner or later we will have to do it when we're absolutely sure. And again, I want to repeat that we have no intention to break any laws. And if we sometimes people say, "Oh, Dr. Podkletnov, you are trying to break Einstein's law," and I want, even with the rotating disks, and I want to remind one more time that Einstein's theory of relativity is good when we speak about relative motion. So every normal motion is relative. But if we speak about the rotation of the object around its own axis, it's not relative motion, it's absolute motion. And the theory of relativity is not applicable to absolute motion. So please, leave Dr. Einstein aside.
That's great. Okay, what's the future? Okay, so obviously you've worked with NASA a bit. What practical applications do you foresee the future for this knowledge here? For instance, vehicles, instead of on the road, are they up 3 feet off the ground, moving around? Are they space travel? Does this answer any questions of black holes, things of that nature?
Well, I can't say anything about black holes because it's a separate topic, and again, I'm not an expert on this. But if we speak about new propulsion systems, definitely these gravity effects can be used. And even at present, the knowledge that we have, if applied properly, can result in very efficient propulsion systems, close to what we call UFOs. Well, in fact, I want to believe that they exist, and I have nothing against. I have never seen one in my life, but from the experience that we have, it's possible to make the objects that will propagate in space using modification of local gravity field, using polarization of vacuum. There are a lot of good theoretical works in this field, and also a lot of practical works. But somehow this is a forbidden area, maybe because there are some traditions in physics, maybe because there are some contradictions. Also, military organizations are always interested in this. Simply, if we speak about anti-gravity platforms or lifters or whatever it is, people say there are some contradictions with physical laws. Well, there are some contradictions, but if we compare quantum mechanics, which is a well-established science in physics, and general relativity, there are enormous contradictions between these two theories, which contradictions in formulas, in understandings, in basics, and the whole scientific world closes the eyes. They don't want to mention it. And by the way, this does not keep people from using both effects. For example, we use Einstein's approach in atomic bombs, and we use quantum mechanics for all electronics and for our portable phones, and both things work, but they have contradictions in theory, and these contradictions are really great. So let's not be afraid of contradictions. It's quite normal. Simply, we don't understand physics well enough, and this is the science which should it's a subject to evolution. So new ideas, new understanding, deeper knowledge that comes with every year. And at present we have good theories, and in various countries there are scientists who are working in the field of experimental gravity research, and I think it's good to pay attention to those works, because the future of our civilization and the future of modern physics will be in this area, and it's absolutely clear now.
You know, I'd like for you to repeat on camera that quote you typed me. I love it. It was, you said something like, the one who controls gravity will control the world?
Well, there are some good sayings. Also, gravity will set us free, but freedom is only for those people who think differently. And so we are trying to think differently, and I think we'll succeed in our research. And the history of science proves it, because we had normal phones, then cell phones, and we had primitive calculating machines. Now we have computers. Now we go to space, and practically there are no limits, unless these limits are created artificially. And that's the thing which I'm afraid of. And there is one more saying that, one more interesting thing. People should approach all new changes and all new research fields with open mind, because a mind is like a parachute. It only works when open.
That's great. Have you, maybe you guys haven't come across it yet, but, and this could be like a very quick answer. When that thing's spinning, does it cause any kind of radio interference? If you had a radio playing, would it create?
No. This installation doesn't produce any bad effects, but if we speak about impulse gravity generator, we put a Faraday cage over the installation. Otherwise, all the computers in the surrounding area will be burned. So there are some still unexplored fields which accompany these effects, and we notice them.
These questions that you wrote down here, do you know what they are specifically?
I can run it. One thing that I wanted to ask, I don't know if it's, it might be kind of off bounds as well, but you're saying that you're using different materials now, as opposed to the superconductors, like normal materials. What would they be?
I'm trying to wait. Hold on a second. You know what? Actually, it's fine. It's not need that gal. Go ahead.
I just wanted to emphasize that it is not necessary always to use superconducting materials for the gravity research, but these materials are very good as model materials. We can practically create whatever magnetic fields we want and use the properties of Bose-Einstein condensate. As far as we understand how the system works, we can move to normal materials, because the key to polarizing space is also rotating magnetic fields, which work in a certain resonance cycle. And in order to create these conditions, we don't need superconductors, we just need normal materials.
I think we pretty much covered this, but I was just wondering on like, this is more for like getting down on the layman side of things, and kind of going back to like the applications and implications of your work. But do you see it? What kind of like the vehicles of the future and the weapons of the future and things like that that may come through this? Or,
Well, first of all, I'm a scientist. I'm not a military person, and I try to keep the results of the research of my team and of my colleagues on the net. It's open to everyone, and I'm ready to have scientific and industrial contacts with any organization that is interested in this research and in these methods. But definitely, everything can be used for military purposes. The planes, the UFOs, if we build one, gravity impulse generator. But they can also be used for the purposes of defense. And if we speak about different space bodies that approach Earth with big speed, or if we speak about to very deep level inside the Earth. If we speak about propagation system, if we speak about communications, so there can be different applications: military, scientific, medical, technical, whatever you say.
Great, that's perfect. I was just wondering as well, what are the general criticisms, or criticism isn't necessarily the right word, but what are the things you generally come up against with your peers with this theory? Because obviously it's a groundbreaking theory. What are the things that kind of challenge people the most?
Frankly speaking, I've never met any serious scientific opposition in this field, because first of all, these results are unique at present. Only several laboratories in the world tried some simplified approach to the same problem, but people who worked in this area for several years, or who contacted me, they are convinced that we are not creating any new science. We are just opening the pages which were not opened before us. Of course, some people say you go against Newton, you go against Einstein, and then these are usually the professors of physics. And then we have a very interesting discussion. Then I say, please, Professor, could you tell me what exactly we are talking about? And after half an hour or even 10 minutes of discussion, we came to a conclusion that most of the professors of physics, they did not study the works of Einstein, nor the works of Sir Isaac Newton. I'm not an expert on their works, but I spent several weeks at the library of the British Museum in London, and I studied the works of Sir Isaac Newton in the original. The language is a bit different, but quite understandable. And I'm not very good at German, though I can read, but I used all the translations from the works of Einstein, and his lectures, and his books, and his articles. And I found that a lot of things, my experiments, the experiments of my team, they prove a lot of theoretical statements that were made by Newton or Einstein. And people who want to criticize me, they practically have no background in this field. So.
I was just wondering, it's kind of not that direct a question, but obviously you've had the interest from NASA that have approached you. Is this something that worldwide everyone's interested in, or are you having to kind of really push the point to get people excited?
Well, NASA is interested, definitely. British Aerospace is interested. People in France are interested. There is enormous interest from China, because they have very good theoreticians in this field, and they are building, slowly but surely, the research program in this field. There are certain difficulties even for people who are working in this area, because if we discuss the problems of gravity or anti-gravity, it's like a red flag. People become excited. It's too unusual to take it openly, because for many years these topics were shown only in the scientific literature or science fiction, and also in some films. So now we need a very good scientific analysis of the situation, and we need to accept experimental gravity research as one of the leading fields in physics. That is important. Even in NASA, NASA is a very conservative organization, much more conservative than British Aerospace. A lot of people are working there. They are normal engineers, rather good engineers, but they have also assistant directors and managers who would like to continue their work in NASA for several years more, and they are not flexible. They try to base their research, even with International Space Station and shuttle program, on the technology of nuts and bolts, and that's not the way to explore space. And the President of the United States, Mr. Bush, made an excellent program for NASA, and he made an interview on the TV concerning the exploration of deeper space. Everything was right, but one thing was missing. They don't have the technology which allows this exploration. So the best thing to do is to concentrate on the modern aspects of physics, on experimental gravity research, and to put even 5% of funding which is available for the International Space Station to this research. And in that case, in 10 years, we can get a new flying vehicle which will fly all over the globe and even to deeper space.
Hold on a second. I can't change my tape.
You do have to change your tape?
Yeah.
Yeah, I've got, I just got the wrong one. I was just wondering if you could elaborate on Eric Laithwaite's gyroscopes and his results in mass transfer.
Okay, just a couple of
Oh, sorry. Yeah,
previous.
yeah.
I don't want to criticize NASA people. They're hardworking people and they're determined, definitely. But the administration of NASA has, in my point of view, poor understanding what should be done. And I have my greatest respect for John Glenn, the first American astronaut and the former member of the US Congress. And he supported with all his forces the breakthrough propulsion system research and the research which was begun with superconductors. And each time he came to Marshall Space Flight Center, he was met with joy and with respect, and people promised everything, and he is a very wise person. He understands what the future is about. But then he left, and the research was slowly stopped, and now it is practically at 0 point. And sometimes people still remember John Glenn and said, oh, he wanted this research to be continued. But then modern administration say, John Glenn is a very old guy. He can hardly understand what is going on. It's their mistake. He understands perfectly what is going on.
Okay. Yes, so I was just wondering a bit about Eric Laithwaite's mass transfer and his linear motor, how that, like especially his gyroscopes and the mass transfer, how that relates to, how that kind of helped you and how that kind of related to your...
As I already mentioned, he was working with absolute motion, that is the fast rotation of the massive body around its own axis, and it's possible also to use the rotation around two axes. So it's a good approach, and when he demonstrated his findings at London Imperial College where he worked, it was a sensation, and everybody could see how he was holding a very heavy gyroscope on his finger, and the gyroscope was about 25 kilos, and he was holding it on his finger, and he was not a very strong man but quite a usual professor, and it's a measurable effect which can be repeated, which can be used, but unfortunately I think 2 months after he demonstrated this effect, he was fired from this prestigious university, and they continue their own line. Professor Laithwaite went to the United States, and he organized a nice research there, but unfortunately he got ill, and soon after that he passed away. So, but that's one more proof that how difficult it is to work in this area. Because modern science is like Holy Inquisition. That's why I'm a bit afraid.
My last one myself, I mean, I'll keep on having a last one. Just again for the layman, I was wondering if you could describe the term 0 point.
0 point energy. Well, it's, let's say it in simple words. We deal with normal bodies. Body can be solid, gas, liquid, and plasma. But we also deal with subatomic particles, which have the size 40 orders of magnitude smaller than the electron, and there are various kinds of these particles. They have their own laws of energy, of mechanical motion, of superfluidity, of pressure, and of let's say coherence, because we can speak about scalar fields, we can speak about coherent vacuum. It's becoming a bit complicated, I understand, but we can deal with these subatomic particles. They form the ether, or the fundamental particles, and the whole universe is made of these particles. So it's possible to extract energy from this sea, from this ocean of particles. It's possible to navigate inside this media. It's possible to create wormholes. It's possible to travel with a speed much more than the speed of light, because the laws which govern these subatomic particles are different. We are now only approaching the stage where we can understand or analyze these laws. They are still not known to us. But nothing stops us from studying them, and gravity research should be one of the first in this field, because it's important for our civilization, important for our future. Well, anyway, it's good to have a flying saucer instead of the car just parked near your balcony. And it should be silver, definitely.
Yeah. Okay, I've got a question here. Is there anything? Okay. Man, a long time ago, looked to the sky and he saw a bird flying, and he said, "I'd like to be able to do that." So he had a model. He had something to build, or to idealize, to dream about, to want to fly. Is there anything that you know about on the planet, besides the disk, that could demonstrate anti-gravity? Well, we don't say anti-gravity. We want to say gravity manipulation.
There are different places on Earth where we have gravity anomalies. There are some places in the United States. There are some places in Britain. There are some places in other countries. Sometimes they are situated on the land, sometimes on the sea surface. And from time to time, these areas become active. Well, we know about Bermuda Triangle. Lots of science fiction things written about these areas, but we also know about different crashes of airplanes, and they happen in different parts of the world. So there are some theories which prove that some parts of our globe have anomalies in gravity properties, in the properties of magnetic fields, electric fields, and when the Earth is rotating around itself and around the Sun, these areas become active in a certain order. And then we have very unusual effects, because if we turn to the statistics of air crashes, sometimes when the plane crashes, it travels about half a kilometer or 1 kilometer, about a mile on the surface, which is understandable, but sometimes the plane crashes and it gives the exact print on the land. And it can be explained only by anomalies in the gravity field. And the Earth still contains a lot of puzzles which we do not know, but which should be studied. So this is if we refer to nature, but also we live in the artificial world, and we have artificial means, and we have even now enough knowledge to make experiments in this field. And these experiments are needed, because each time I see the shuttle going to space, I understand that it is a very big bomb going to space and a very big risk for the astronauts. That's why applying new propulsion systems and the systems which allow to operate with gravity forces, we can make those trips much safer, much easier, and less expensive than the existing programs. Also, if we deal with energy production, these new methods will allow us to extract energy from different sources and to stop that the use of oil, which in my understanding should be used not for the vehicles, but only for chemistry, new plastic materials, or something of this kind.
I agree with that. I'm going to get over the shoulder here real quick.
I was just thinking, did you cover the way that in future, like interstellar exploration, obviously you use the gravitational pull of different planets to give you a lot of your propulsion, but how would a gravitational manipulation device work? Would you have to kind of see where the nearest gravitational field is and like take planets as you go past them, or I don't kind of understand this. I wonder if you could expand on that.
Well, I have some projects which were created in collaboration with, and some drawings, in collaboration with my American colleagues and my colleagues from Italy, from Great Britain, from Russia, and from China, also from Canada. Sorry, I forgot. And it's possible to use Biffle-Brown effect, which is a kind of electrostatic propulsion, and to use the phenomenon which we call the polarization of space. When we create the polarization of space under the conditions of normal Earth, that means that we create a kind of a gravity well, and all the subjects, all the objects that are close to this area, they will fall into this well. So we observe this phenomena as a UFO or any flying disc which goes up, but in fact, speaking in physical terms, that means that this object is falling inside a gravity well. So this is about how we can propagate close to the Earth. If we speak about other planets, it's a bit early now to discuss how it can be done, but using the same principle, polarization of space, and a possibility to move in the media of subquantum particles, everything is possible. But as I mentioned, first of all, I am not an expert on gravity. Second thing, I'm not a magician. I'm just learning. Maybe I will become one.
Pull this back, guys.